In this video, I will show you how to write and graph the equation of a hyperbola. Now, a hyperbola looks like this. It comes in two branches. It has vertices. It has foci. It has asymptotes. These dotted lines are asymptotes. It has an A value and a B value. The A value is the distance from the center to a vertex. The B value is the distance from the center to a co-vertex, even though the co-vertex is not actually a point on the hyperbola. There is a C value. That's the distance from the center to the focus. And the equations look like this, very similar to the look of an ellipse equation, except for instead of a plus like an ellipse has, a hyperbola will always have a minus. That means there will always be a positive term and a negative term. Now, the positive term always goes first. If the positive term is the x term, then the hyperbola will open horizontally, left and right. If the first term, the positive term, is the y term, then the hyperbola opens vertically, up and down. When we talk about a hyperbola being horizontal or vertical, sometimes they will talk about the transverse axis. Let me make this a little bit bigger. Okay, this is the transverse axis, a segment connecting the vertices. So for a horizontal parabola, we could say that the transverse axis is horizontal. When I talk about a vertical hyperbola, the transverse axis is vertical. The center of the hyperbola is still given by h and k. Just like for an ellipse or even a circle, h comma k is the center. Of course, the center is not on the hyperbola. For ellipses, the a squared value is always bigger than b squared. That's not necessarily true for a hyperbola. For a hyperbola, the a squared value will always be the denominator of the positive term. The b squared will always be the denominator of the negative term because the a squared value has to lead you to the vertex. And like I said before, if the first term is the x term, it's going to be horizontal. So by letting the first term, the first denominator always be the a value, then the a value will always lead you to a vertex. The b value is for a co-vertex. Enough talk. Let us graph hyperbola number 1. Remember, the center is going to come from h and k. If I see x squared and y squared only, then I know the center had to be 0, 0. So even though the center is not part of the hyperbola, we should graph it for reference. That's the center, that blue dot. Now let us find the vertices. We will find the vertices by learning the a value. Remember, the first denominator, the positive term denominator, is always going to be a squared for a hyperbola. That means a is 4. Notice that the 16 is the denominator of the x term. So I'm going to do plus or minus 4 in the x direction. So if I go left 4 and right 4, these will be my vertices. So by the way, remember, we already know that the branches will open left and right. Because the first term, the positive term, is an x term, we know that the hyperbola will be horizontal. So we have the vertices. Now, the b value, the negative denominator, the second denominator, will always be b squared. That means b is 2. Notice that this 4 is with the y term. So I will do plus or minus 2 in the y direction. So if I go up 2 and down 2, these are my co-vertices. Now, a hyperbola has asymptotes. The way we can find the asymptotes is by drawing a rectangle. Draw the rectangle that contains the vertices and the co-vertices. All right, make it dotted because this is definitely not part of the hyperbola. This is just a guide. Okay, now the diagonals of the rectangle that we just drew will be where the asymptotes go. The asymptotes pass through the diagonals of this rectangle. So one asymptote will go like this. Okay, and draw the asymptotes as dotted lines because they are just guidelines. Oh no! I just had to redo that whole thing, so I just went ahead and drew it with objects to make it go a little faster. So these dotted lines are the asymptotes that I was drawing a minute ago. So we could actually go ahead and draw the hyperbola right now. Remember, these red dots are the vertices. So the branches should start at the vertices and approach the asymptotes on either end. Okay, so your hyperbola should look very much like that. We still need to find the foci, or foci. There should be one in the interior of the left branch and one in the interior of the right branch. It is the C value that leads us to the foci. When it comes to hyperbolas, the relationship between A, B, and C is C squared equals A squared plus B squared. For ellipses, this was a minus. For hyperbolas, it's a plus. So C squared is equal to 16 plus 4. So C squared is equal to 20. That means C is equal to the square root of 20. And since 20 is 4 times 5, that means C is equal to 2 radical 5. So there we go, 2 radical 5. For graphing purposes, it would be useful to have the decimal approximation for this. So C is approximately equal to 4.5. And that tells us where to place the foci. We will go 4.5 to the left and right of the center. Okay, so here's 4, so 4.5 would be about here. So there's a focus. And here's a focus. Now, when we label these, we can't use the 4.5. We need to use the 2 radical 5. So if I start at the center and I go to the left 2 radical 5, then that means the x value here is negative 2 radical 5. The y value is 0 because it's on the x-axis. So this focus, oh, you know what? I guess they didn't actually ask us to list that. They did ask us for 0, 0. If they did have us label the focus, this one would be negative 2 radical 5, 0. And this one would be positive 2 radical 5, 0. Usually we ask you for those. This time it looks like we didn't. The eccentricity is always the C value divided by the A value. So that's going to be 2 radical 5 divided by 4. 2 goes into 4 evenly, so this is going to reduce down to radical 5 over 2. Okay, so it does say identify the vertices, the foci, and the asymptotes, but then they just don't list them in the box. Oh, it's down here. Okay, so the vertices are negative 4, 0, and 4, 0. The co vertices, these purple dots, are 0, negative 2, and 0, 2. And the foci, we just talked about that, are negative 2 radical 5 comma 0 and positive 2 radical 5 comma 0. All right, now let's talk about the asymptotes. You can always find the asymptotes using a point-slope form, the point-slope form equation of a line. If you simply use the center, if you choose the center as the point, because the center is the one point that's on both lines. So here's a model that will always give you the asymptotes. Y minus k is equal to plus or minus m, and then times x minus h. Now, the h and k, these are the center, like always. Okay, so let me just write center, and that's the that's the h and the k is the center. Now the m is the slope. Okay, or slopes, thus the plus and minus. So for this particular problem, the center is 0 comma 0. Remember, all right, the center is 0, 0. So that means the h and the k are both 0. So all I really need is the slope then. What's the slope? The center was 0 comma 0. So the slope, just pick one of the lines and analyze the slope. Okay, if I stare at the corner of this box, then I find myself thinking, up 2 and over 4. That's the rise and the run. So the slope is 2 over 4, or 1/2. All right, rise over run, the slope is 1/2. And this is positive 1/2 because it's uphill. The slope of the other line, the downward line, is down 2 over 4. So that's negative 1/2. Okay, so we have a positive 1/2 and we have negative 1/2. So that's why for the slope, we will just put plus or minus 1/2. And then we just have the y equals and the x, because h and k are 0. So this is how you can easily find the equation of both asymptotes at once. All right, take a look at problem number 2. Again, we see the x squared and y squared, and we know the center will be 0, 0. So let's go ahead and record that. Now, we will need a and b to find the vertices and co-vertices. For hyperbolas, the first denominator will always be a squared. The denominator of the positive term is a squared. Therefore, a is 5. Notice how the 25 is with the y term, so I'm going to do my plus and minus 5 in the y direction. In other words, I will go up 5 and down 5 from the center. These are my vertices, ladies and gentlemen. So I could write that down right now. So 0 comma 5 and 0 comma negative 5. Okay, those are my vertices. Now, how about those co-vertices? For the co-vertices, I need the b value. B squared is always going to be the second denominator, the denominator of the negative term. So b is 2. Notice that the 4 is the denominator of the x term. So I will do my plus and minus 2 in the x direction. So that's why I will go 2 to the left and 2 to the right. These are my co-vertices, negative 2 comma 0 and 2 comma 0. All right, now we need to form the asymptotes. The way we do that is by drawing a rectangle, the rectangle that contains the vertices and co-vertices. So make a dotted line and draw the rectangle that contains the vertices and the co-vertices. We need this rectangle because the diagonals of the rectangle will show us where the asymptotes are. So the asymptotes, okay, so this is up 5/2. The asymptotes will pass straight through the diagonals of this rectangle. Okay, so you can see the asymptotes. Right now, we could graph the hyperbola. Remember, these red dots were the vertices, so my branches should be at the red dots and approaching the asymptotes like this. Whoops, too far. Okay. All right, I should point out that I knew that this hyperbola would be a vertical hyperbola, opening up and down, right from the beginning. As soon as I see that the first term, the positive term, is a y, then I know it's going to be a vertical hyperbola. If the first term, if the positive term is an x, that's when it's going to be horizontal like this one was. So we've graphed the hyperbola, but we haven't graphed the foci yet. You can get the foci by using the following little equation. C squared is equal to a squared plus b squared in hyperbolas. So that means c squared is equal to 25 plus 4. So c squared is equal to 29. So c is the square root of 29. For graphing purposes, it would be helpful to have a decimal approximation. It's approximately 5.4. Now I know the foci should be sitting here in the interior of these branches. So this is 5.4 will be about here. And if I go down 5.4, that's going to be about here. So now I've graphed the foci. Now when I label them, I have to be careful. I can't use the 5.4. I need to use the radical 29. So look, it's clear that the x-coordinate is going to be 0. It's sitting right on the y-axis. So I know that both of these foci are going to be 0, comma something, because they're both sitting on the y-axis. Now, for the y-coordinate, keep in mind that we started at a center of 0, and for this one I went down radical 29. So that's 0 minus radical 29, or negative radical 29. For the upper focus, I went up radical 29. So that's positive radical 29. So those are the coordinates of the foci. Okay. While we're here, let's go ahead and write what the eccentricity is. The eccentricity is always c over a. So that's going to make it radical 29 over 5. Okay, what's left? Oh, we need the equation of the asymptotes. Remember, the equation of the asymptotes can always be written with using the following model. What I'm about to write down is really the point-slope form of a linear equation. But I'm purposefully using the center as the point. So I will put y minus k is equal to plus or minus m times x minus h, where the h and k are the center, like always, and m represents the slope of the asymptote. So in this particular problem, the center is 0, 0. Okay, for that reason, the h and k are both 0. This is 0 and this is 0. So those are basically gone. The slope, let's talk about that. Just pick either one of the asymptotes and use the rectangle to help you easily see the slope. From this point to the corner, what is the rise and the run? Well, it's up 5 over 2, so that's the slope. Okay, so the slope right here is 5 over 2. So the asymptote equations will be y equals plus or minus 5 over 2x. Again, the h and k were 0, so I didn't write them down. The reason why I have plus or minus is because I have two asymptotes, one with a positive slope and one with a negative slope. So that is it for problem number 2. In this video, I will show you how to write and graph the standard form equation of a hyperbola. Now, I know this is the equation of a hyperbola because x is squared and y is squared, but one is positive and one is negative. For the standard form equation of a hyperbola, we should always have a 1 over here on the right-hand side. That's how I know to divide by 40, so I can get 1. We have to reduce these fractions down. 2 goes into 40 20 times. So this is going to be y squared over 20, okay, is equal to, well, minus x squared over 4. All right, 10 over 40 is 1 over 4. And this is equal to 1. All right, so this is the form of the equation I'm going to use for the rest of the problem. Now, some hyperbolas are vertical, meaning they open up or down, whereas some hyperbolas are horizontal. They open left or right. This is going to be a vertical hyperbola. I know this because the positive term has the y in it, and we should always put that first. So just right from the beginning, you should always know which direction your hyperbola is opening. So this one opens up and down. Keep that in the back of your mind. We know that the center of this hyperbola is going to be 0, 0, because we just have x squared and y squared. We don't have x minus 5 or anything like that. So when it's just x squared and y squared, the center is 0, 0. So there's your center right there. Now let's find the a value, because that will give us the vertices. The first denominator, the denominator of the positive term, is always going to be a squared. So a squared is equal to a squared is equal to 20. That means a is equal to the square root of 20. So that means a is equal to, square root of 20 is 4 times 5. So the square root of 20 is 2 radical 5. It would be helpful to know the decimal approximation for graphing purposes. The a value is approximately 4.5. So notice that this 20 is the denominator of the y term. So I'm going to do plus and minus 4.5 in the y direction, and that's going to give me the vertices. So if I go up 4.5 and down 4.5, these are the vertices. Now be careful, when I write these down for my final answer, I cannot use this decimal approximation. I'm going to say 2 radical 5. The x coordinates are 0 because they're right on the y-axis. So I'm going to say the vertices are 0, negative 2 radical 5 and 0, positive 2 radical 5. Those are my vertices. Okay, Now we need the b value so we can get the co-vertices. The negative denominator is always going to be b squared. So b squared is 4, which means that b is 2. Notice that the 4 is the denominator of the x squared. So I'm going to do my plus or minus 2 in the x direction. In other words, left 2 and right 2. These are my co-vertices. Negative 2 comma 0 and 2 comma 0. Okay, so look, the b value was 2, and I forgot to write down that the a value was 2 radical 5. Let's go ahead and draw the asymptotes, because the asymptotes, to find the asymptotes, we need to draw the rectangle that contains the vertices and co-vertices. So draw yourself a rectangle using dotted lines. Okay, draw a rectangle containing the vertices and the co-vertices. Okay, so the diagonals of the rectangle, the asymptotes will pass right through those diagonals. So I can tell that I'm going to have an asymptote that goes like this. All right, and I will have another asymptote that goes like this. All right, we could draw the branches of this hyperbola right now, because remember, these red dots are the vertices. So that's where the branches should be. One should be at this vertex and approaching the asymptote on either side. And we should have another branch at the other vertex. Again, approaching the asymptotes on either side. Okay, so a vertical hyperbola just like we predicted right from the beginning. Let's find the foci, which should be in the interior of each branch. To find the foci, we're going to need the c value. So remember the relationship here. Okay, maybe I'll do it over here. When it comes to hyperbolas, we know that c squared is equal to a squared plus b squared, unlike ellipses, which have a minus right here. So c squared is going to equal 20 plus 4. So c squared is equal to 24. So c is going to equal the square root of 24. Now remember, 24 is 4 times 6. So that means c is going to equal 2 radical 6. For graphing purposes, it would be useful to know the decimal approximation. It's approximately 4.9. So here's 4. So 4.9 would be right about here. And if I go 4.9 in the other direction, that's right about here. When I label these, I cannot use 4.9. I have to use 2 radical 6. So the lower focus is the point 0, comma, negative 2 radical 6, because I went down 2 radical 6. And the upper focus is at 0, comma, positive 2 radical 6. Okay, of course the c value is 2 radical 6. Let's go ahead and speak of the eccentricity. The eccentricity is always c over a. So in this case, we have 2 radical 6 over 2 radical 5. Those 2's cancel each other out, so I have just radical 6 over radical 5. I feel like we should rationalize the denominator. We can rationalize the denominator by multiplying by radical 5 in the numerator and the denominator. So then we will get radical 30 over 5. Let's write it that way. Radical 30 over 5. There's your eccentricity. Now we need the equations of the asymptotes. So remember, here's a model for the equations of the asymptotes of any hyperbola. Y minus k is equal to plus or minus m times x minus h. Now this x minus h and y minus k should be looking familiar because the h and k are the center like they always are. So really this is just point slope form of a linear equation. M is the slope and the point is the center. So because the point we're using, the center is 0, 0, then that means we're just going to substitute in 0 here and we're going to substitute in 0 there. So these are basically gone. All we need is the slope. What will the slope be? Well, just pick one of the asymptotes and check the rise and run. Now be careful because this is a decimal, so remember what this was. This was the a value. So the rise is this a value of 2 radical 5. So when we talk rise and run, it's 2 radical 5 and then 2. So it's 2 radical 5 over 2. Okay, so think about that. So the slope is rise over run, 2 radical 5 over 2. The 2's will cancel out. So the slope is actually radical 5. So we will have plus or minus radical 5. So the following expression will represent both asymptotes. Y equals plus or minus radical 5 times x. I don't even need parentheses. Okay, and that's it. Now if you really wanted to be clever, you might write y is equal to plus or minus x radical 5, because normally if you have a radical and then a variable or a number, you put it before the radical. But I will accept either one. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.